So these are the rats that you can tickle and they laugh.
Yes, these are, very friendly domestic rats. We would not want to tickle a sewer rat or a wild rat, but these are, even though I haven't handled this one at all, it's pretty friendly and not much to worry about, especially if they're female.
Right. So how you tickle them? How you make them laugh?
Well, you have to get friendly with them and you turn them down. And
It looks like they like it.
if we had the ultrasonic equipment, you would hear. So this is our way of evaluating where they are in emotional space.
So it looks like the equipment is here now.
Oh, you have one of those. Wonderful.
So you use this one to measure, to hear it, right?
Yeah, this is. Usually on the first day they're scared and they're, a little bit, a couple of chirps, but. I mean, every experiment you handle the animals, you habituate them. It's not like this animal that you just pick up that you've never, it hasn't been handled for a while, has it?
No, it actually hasn't.
So
He's pretty skittish.
Oh, yeah. But still,
Oh, she looks friendly.
Calming down too.
It's a, it's a totally new situation.
So how long it took for you to kind of understand that they actually make some laughing sound?
Well, we had been studying social processes in the brain. Spent a lot of time on, the anxiety one feels when one's young and left alone, separation, distress. And then we wanted to study, what makes animals feel good. And of course, that's play. And play is built into the brain. And we studied play for a long time, 20 years.
On rats?
Oh, yeah. And then, we started measuring the vocalizations in the late 1990s. And, we discovered that there was a play vocalization. So you can't hear it with your own ears. You have to have special equipment. And we studied the play vocalization for many years. And then one morning I thought maybe it's like laughter. And I came into the lab and asked my assistant to come help me and let's tickle some rats. So here we go, kutsi, kutsi, kutsi.
And you said in your research that the same emotions that you can observe on rats, they actually are happening in our brain too.
Well, we're all mammals and we all share a common ancestor. How many millions of years ago would the common ancestor be? Well, maybe 25, 30 million. And, we were already very sophisticated creatures and the emotions are very primitive in the brain. So once you have a solution in the brain, all mammals will have a similar solution. In principle, they will not be identical. But, the brain never throws away a mechanism that's very valuable for living. So, we all understand hunger and thirst. They have to be built in. But the emotions, those have been more ambiguous for people because they have so many words. And a lot of people do not believe that rats have emotions, but they're wrong. If they spent any time working with the animals, they would realize they're very emotional creatures. And we know that there's at least 7 that are built into the brain. And we know that because we can stimulate the brain in very specific areas and turn on at least 7 emotions. One is the emotion of curiosity, exploring the world, finding things. We call that the seeking system. Of course, some animals would want the same resources you want, so you sometimes have to fight. There has been anger, a resource system. Some animals see you as a resource. So the big predators, many millions of years ago, long-toothed, saber-toothed tigers, we were scared of them, wolves, so every mammal has a fear system. And of course, you can't be a mammal without reproducing, so there has to be a sexual system for males and females. And once you have a lust system, you have to take care of the babies. To be a mammal is to be a social animal, and the mother has a very powerful care system. Males also have this system, but it's not as sensitive, so it has to be trained a lot more. And so there's a care system, and of course the little ones have to indicate to the parents that they're lost, because in the real world, little ones get lost. So there's separation, distress, and panic system. And the last big system that we can be confident about is the play system, because mammals have to learn social rules, but these rules are not built in genetically. They have to be built in by interacting. So there's this powerful system to increase positive social interaction. And that's where we discovered this happy sound. And now we've been using the happy sound as a guide for developing antidepressants. And we're looking for molecules that make you feel good, as opposed to just, chance findings. Everything in biological psychiatry so far has been serendipity, a chance finding. But of course, if you want to follow a scientific approach, then you can take just behavior, but behavior doesn't tell you the emotion, so you have to study the actual emotional systems. And if you want to make sad people happy, depressed people happier, you have to find the brain mechanisms for happiness. And that is what the rats have given us, basically.
So you said 7 primary urges. What do you call them?
Seeking, looking for stuff, rage, competing for stuff, fear, protecting yourself, lust, so there's sexual reproduction, maternal care, making sure the young can grow up nicely, separation distress, the loneliness of being alone, the pain of being alone. We call that the panic system because we think panic attacks emerge from that. And finally, there's a play system. And we capitalize these words: seeking, rage, fear, lust, care, panic, and play, because these are special built-in systems. We call them primary processes. And on top of that, you have learning and memory. Most people have been studying learning and memory. We're interested in the instincts, the rules for living that are built into the brain, because you will never really understand learning and memory without understanding the lower level, the more ancient level, the emotional level. And then the learning and memory is very important. And of course, we humans have an enormous brain, and we can think, we've got complex cognitions, and that's what the top of our brain does. But the top of our brain does not control consciousness. It does not generate consciousness. It's already built low down.
So what's happening with this rat? There is something on his head.
Yeah, my colleague Casey Cromwell is recording from the seeking system, which is probably the largest emotional system in the brain. Without the seeking system, the animal is super depressed. It can't do anything. And one thing that we've been conceptualizing is that depression, at least certain kinds of depression, are low activity in the seeking system. And there are pharmacological ways to increase it, but many of those drugs are addictive. But we do have one drug that is not addictive, that can elevate the system as indicated by the happy sounds. And we've also, with colleagues in Germany, physicians, neurosurgeon Thomas Volker-Können and Thomas Schapfler, who's a biological psychiatrist, they have now stimulated the human seeking system in 7 patients, and 6 of the 7 that have not gotten benefits from other things, direct deep brain stimulation of the seeking system has brought them back to almost normal.
Interesting. So I wanted to ask also here, where you get those rats for the experiments?
We breed a lot of our own rats. Sometimes we bred for happy rats. the ones that make many of these 50 kilohertz laughter type sounds.
So you can breed happier rats?
Of course, yes.
So
yes.
what's the special secret there?
Well, the secret is genetics, of course. We would like to know the genes that control happiness, because those are the genes that you want to promote in depression, and or at least the products of those genes. And that is how we discovered this antidepressant that is now in human trials. This elevated the happy laughter type sounds in animals. We worked out what genes are elevated by playing, the happiest time animals have. And we found the genes that are elevated, and we simply took the first gene to ask, can that gene elevate happiness in rats? And it was insulin-like growth factor 1, and it's a very powerful facilitator of positive affect. But that also increases tumor growth. So we went to the next gene, and it ended up being a part of the glycine receptor, and we developed medicines for that receptor that didn't exist before. And one of these has gone through human testing, and it has been better than anything they have so far. So we can now use animals as emotional models as opposed to just behavioral models.
So you know those happiness genes?
We know some of them. We certainly don't know all of them, but we found enough to go to medicinal development.
In New York, we talked about the experiments with animals, and you have a very certain position on them. There are people who are absolutely against them. What do you think? Are they useful, needed?
Well, I think many people say, they've said for 100 years, that you cannot read the mind of an animal, and therefore we simply have to stay at a behavioral level. And we all appreciate that a behavioral analysis is easier and very important.
Behavioral is just observing them.
Exactly, what the animal does, presses levers, runs mazes, in our case plays, fights, looks for things. We have been interested at a level of the brain that other people haven't even really thought about, that what evolution actually gave the animals as tools for living. If you don't understand those, the rest of the brain will be very confusing, because all the more recent developments are based on what was built in. We call these built-in things primary processes. There's many of them. In the behavioral analysis had 2 words for these. The unconditioned stimuli coming in, like a knee-jerk, pressing the patellar reflex. Also the unconditioned responses, like you shock an animal, the animal goes, eh. Now that's an unconditioned response. The animal also runs away. That's an unconditioned response. So people think of the unconditioned response simply as an output of the nervous system. They haven't learned to think about some of them as being organizing principles in the brain. Now, emotions you see when an animal is emotional, and we've been looking at these emotional systems in the brain, and we've also been asking, does it feel like something? Namely, is there an experience to it? And the only way we can ask that, we can't talk to animals, but we can ask them, do you like to turn this circuit on by pressing a lever? And the seeking system, they love to press it. We can also ask animals, do you like to turn it off? And the answer is yes, there are circuits you don't like. Certainly anger, rage, and fear. If you turn it on, the animal turns it off. That means it's a punishment. And a punishment for humans means it feels bad. There is no punishment that does not feel bad for us. And we're willing to say, we're just mammals, they're just mammals, we're smart mammals, they're clever but not so smart. But the feelings are the same. So wherever we produce a fearful feeling in our brain, and the animal runs away with similar stimulation, and the animal turns it off, that means it's a punishment of a similar kind. We never say it's identical. And that's one reason we capitalize the words, because that tells you it's a scientific word and not just the everyday word of fear or rage. The capitalization means it's a special circuit in the brain, and we can defend its existence. And we can defend that the animal has a feeling. Now we're actually studying consciousness. And my argument is that this is the most powerful way to understand consciousness scientifically. If you can do science on one experience, then you might be able to work up to more complex experiences. But if you don't understand the foundations of experience, you will never understand the rest. Now, this seems to be a novel argument, but I think it's the correct one. It's an evolutionary argument, and we're very evolutionarily oriented. Many brain scientists are not. And our feeling is that you have to understand the most earliest solutions very clearly before you understand the other solutions. So we'll see how it goes.
These tests are important.
We have no way of studying these circuits in the human brain.
But those animals
We can
observe
actually
it.
study them scientifically in detail, and we can also argue not just on the basis of credibility, but on the basis of data, that we have similar systems. You know, as far as the body is concerned, we've learned more about the human body by studying other mammals than humans. Without the study of the other animals, our medicine would be very primitive. And we're arguing that psychiatric medicine will be the same way, because psychiatric problems are emotional problems of the brain. And if we share very similar emotional systems, if we understand their chemistries in our little rats, we will, for the first time, understand them in the human brain. That is a debatable argument, but it's an evidence-based argument. So we try to generate a vision that can be falsified. You know, we can tell people, if you do this and it does not happen, this prediction does not work, we are wrong. That is the highest value of science, that you follow the evidence. And it's the weight of evidence that controls what you conclude. Right now, in many areas, we're still in the area of belief. One of those big beliefs is that we can never understand what a rat experiences. We can't understand what they're thinking about. We can't even say they are thinking, but we can say they're feeling. And their pain is similar to our pain. Their hunger is similar to our hunger. It's not identical, but the principles are the same.
And the laughter is similar to our laughter.
Exactly. You know, little babies laugh when they're 6 months old. They don't have any language at that point. And the laughter is an old way to communicate. So why would it not be something we share with the other animals? I mean, we were surprised, and we tried to demonstrate that we were wrong, namely falsify our ideas. And we did about a dozen experiments that could have gone either way, but they were on the side that this is something resembling laughter. And that's what scientists do. They go with the evidence. And that's what we've been doing. But in this area, because of history, and the history says we can never understand what an animal experiences. Our attitude is if we experience, it goes back to other animals. It was not born with us. You know?
So this is the device you measure, or you listen to the rats.
Yeah, this is one of the devices. We have more sophisticated computer ones, but this is called a bat detector. The reason it's called that, bats, when they're hunting at night, they're sending ultrasounds and finding insects by the reflection of the sound. So these can pick up sounds that we can't hear. For instance, my fingers, you can't hear, but if I am doing it right here, you can hear it. So when a rat is laughing, you hear nothing at all, but when we tickle it, then it starts making these little chirpy sounds that are almost like you stop, and then you move your fingers and they follow it and still make some of these sounds like, are you still there? And you know, we have mapped the brain with deep brain stimulation. So we know what the circuits are for this happy sound. And the reason we know it's happy is because wherever you produce a chirpy, chirpy sound and the animal's given a chance to turn it on, the animal turns it on. Presses it to get that change in the central state. So that is a positive feeling, empirically demonstrated. And you know, we spent a lot of time looking for the chemistries, new chemistries in this system. And we have found some of them, not all of them. And it's the first animal model for psychiatry that takes the animal's feelings seriously. And this gives us a new level of knowledge, a new level of understanding, and possible ideas for medicines that have never existed in human imagination.
So you said you were studying rats for 20 years before one morning you woke up and said, let's see if they laugh. How was the story?
Well, the story was very simple. We had been studying playfulness to animals, engaging and running around and wrestling, basically. And, you know, we had learned many of the lessons of how to study this behavior systematically in the laboratory. It turned out to be quite easy. We were interested in the chemistries that control this, and then the brain mechanisms that control this. And one day we decided to simply ask, do animals make sounds? Are there play sounds? We weren't even thinking about laughter, just play sounds. When some animals play in the wild, they make certain sounds, humans laugh. It turned out that the rats were making these happy little sounds, or you know, 50 kilohertz ultrasonic vocalizations. And we studied those for about 5-6 years, and I just woke up in the morning and thought, maybe that is laughter. And I came to the laboratory here, and one of my students, Jeff Bergdorf, was waiting for me, and I said, Jeff, let's go tickle some rats. And I just tickled a little rat the way I would tickle a little child. I know how to tickle a child. And when you tickle a child, they want to be with you. And the first animal, young animal, I did it on, the animal went, second animal, third animal, every animal. You know, some were very, very loud and high, others were not. It turns out the ones that are very loud and high are happier animals by every measure that we collected. The ones that don't show so much are more sad and more prone to depression. So we're getting at the emotional personality. And we even developed a personality test for humans based on emotions for the first time. So we were captivated by this phenomenon. And we studied it many different ways, and the most recent has been the genetics of it, the neurochemistries that the genetics suggests, and then going into the human psychiatry situation. And we have now tested one, GLIX13. This is with my colleagues at Northwestern University, Falk Center for Molecular Therapeutics, Joe Moskow's group, where Jeff Bergdorf is right now. And we have this molecule called GLIX13 that came from the genetic analysis that went through animal toxicology, was very safe. It went through human toxicology. There was no bad effects in humans. And it has gone through the first FDA, Food and Drug Administration, stage 2 testing. And that testing finished in September of 2012 this year. And it was much better than any antidepressant statistically.
Okay, so what's going on there? What is it?
Okay, this is for pigeons. And we know that pigeons navigate and they know the space, enormous amounts of space in the world. and they can actually detect electromagnetic waves. And this is the first time that Cordelia Mora and Dr. Vern Bingman have put together an apparatus where with electrical wires in all directions, they can actually generate different electromagnetic fields and see how pigeons organize information based on that knowledge. So they are finding that the birds can actually have this fantastically sensitive detection of electromagnetism that we cannot experience as human beings. And they're even finding that animals like certain patterns of electromagnetic energy better than other patterns.